myself Nitin Chauhan, and I'm Assistant Professor of Mathematics in the Department of Mathematics from School of Engineering Technology. And we are starting today differential equations. So first of all, tell you what are differential equations. So here is the introduction. Actually, we have the derivative, this dx upon dt, and this is the derivative of a dependent variable with respect to independent variable. Here we assume that d upon dt is this d upon dt is a change. This is known as change, and when this change happen, dx upon dt, if it means if this x is an event, then the change of that event with respect to time is known as derivative, and the equation which involve this dx upon dt with respect to independent variables and dependent variables, that it is known as differential equations. Okay, so now we are starting what are differential equations. So this is a differential equation, and first of all we start order of, we write differential equation as DE, the order of DE, differential equation. What are the order of differential equation? The order of differential equation is that the highest order derivative involved in the differential equation is known as the order of that differential equation. Mean that, for example, d2y upon dx2 plus 4y equals to e to the power x. Here this is the derivative and this is the highest order derivative, and the order of this highest derivative is 2. So the order of this differential equation is 2. Okay, so after that we are starting the degree of differential equation. What are the degree of differential equation, students? Degree of differential equation is that the highest power of the order of derivative which is free from, which the derivative is free from radicals and fractional powers. Okay, so for example, we take the example d2y upon dx2 plus, sorry, not plus, equals to 5 plus 7 dy by dx raised to the power 2, and here it is power 3 by 2. Okay, so the degree of d2y upon dx2 is 1, but this is not the actual degree. As I told you that the derivative is free from fractional power. He is a fractional power, so we have to remove this fractional power. Okay, for the fractional power removation, we square both sides of differential equation. Okay, when we square it, what we get, d2y upon dx2 raised to the power 2 equals to 5 plus 7 dy by dx raised to the power 2, 3 upon 2 into 2. This 2 to cancel. Now the derivative is free from fractional power. So here order, first of all I'll tell you order. Here order is 2. How? d2y upon dx2. There is a 2 order. That's why the order of differential equation is 2. Okay, and degree. What is degree? Here degree is 2, because this is the highest order derivative and the power of highest order derivative is 2. This is also a derivative, but it is not a highest power, highest order degree. The highest order is this one and its power is 2. So the degree is 2 and order is 2. So by this method, we easily get the degree and order of the differential equation. Now we start differential equation of first degree and first order. We start differential equation D of first order and first degree. Okay, first order and first degree. First order and first degree means the differential equation is this type: dy by dx equals to function of xy. Mean that the derivative involved in this type of equation is a first order and first degree. Okay, this is a first order and first degree differential equation. Or just it is also this kind, m dx plus n dy equals to 0, where m and n are function of x and y or constant, friends. Okay, this is the differential equation of first degree and first order. Okay, now we just start some methods of solving this sort of differential equations. Okay, So for the solving of this differential equation, we have two methods. There is a lots of methods, but today we are going to start. We are going to I am going to introduce you only two type of. First is variable separation method. Okay, student, this is a method, variable separation method. By the name, we can separate the variables differently. After that separation, we easily solve them by integration. Okay, so we have just like we have differential equation of this type, dy by dx is equals to function of x upon function of y. There is some function which are function of x only, and there is function of y only. So how we going to solve this equation? By the variable separation method, we just cross multiply them. Okay, fy goes to here, so fy dy is equals to fx dx. Okay, so fy dy minus fx dx is equals to 0. Now on integrating, after integration, there integration fy dy minus integration fx dx equals to c. This c is the constant of integration. Why this comes? Because when we differentiate or when we integrate the function, there is some constant of integration, which is this one c. Okay, and after the integration, we easily get the solution of the given differential equation. Okay, so students, let me explain you this by example. Okay, there is example y minus x dy by dx is equals to a y square plus dy by dx. Okay, students, this is the differential equation, and we are going to solve this differential equation by the variable separation method. Okay, so first of all, y minus x dy by dx is equals to a y square. We just multiply this a to both the values, so a dy by dx. Okay, now we separate them. Okay, y, we shift this a y square here, so y minus a y square is equals to this a dy by dx as it is, and this goes to there, then it convert into plus, so x dy by dx. Okay, now y minus a y square is equals to, we common this derivative dy by dx, so the equation becomes x plus a dy by dx. Okay, now what we are going to do, we just shift it here. Okay, y minus a y square upon x plus a is equals to dy by dx. After that, okay, we shift here and we put this dx like this. Okay, dx upon x plus a, okay, equals to dy upon y minus a y square. Okay, why we do this? Because when we integrate it, dx with dx, there is only a function of x, and with dy there is only a function of y. Okay, students, now we integrate it. Okay, so here we start the integration of this one. Okay, so integration, we put the integration sign here. Oh yeah, on integrating. Okay, so this is directly changed to, what is this, 1 upon x plus a, then the integration of this is log x plus a. Okay, log x plus a, and here I just write it here, dy upon, we just 1 minus a y. Okay, we just common the y. Okay, now after this, how this is going to start integrate? Okay, so just we use the partial fractions here. Okay, we use the partial fractions here. So the partial fraction, what is the partial fraction? Okay, so just I explain you here. how we going to solve this? So this is a partial fraction, 1 upon y 1 minus ay, okay, equals to, what is partial fraction? We just change this multiplication sign into plus or minus sign, okay. For this we just change it here like this, a upon y plus b upon 1 minus ay, okay. Now after that we just solve this by taking LCM. The LCM is here this 1 upon y 1 minus ay as it is, okay students, and here y 1 minus ay, and this a multiplies to 1 minus ay plus b multiplied to y, okay. Then this denominator part cancel out, then we have only 1 equals to a 1 minus ay plus by, okay. Just I am removing this one part, okay, for solution, and this one part, okay. Now we just calculate the value of a and b. For the calculation of a and b, we just assume, okay, we put y equals to 0, okay, y equals to 0, y, if you put the y equals to 0, what we have, 1 equals to, if we put y equals to 0 here, then 1 equals to a as it is 1 minus this 0 plus 0, okay. So then we have a equals to 1, a equals to 1, and when we and after that, now just a minute, 1 minus ay equals to 0, 1 equals to ay, or y equals to 1 upon a. Now we put, for the value of b, y equals to 1 upon a, okay. When we put the y equals to 1 upon a, then this a cancel out, okay. When we put y 1 upon a, then the a cancel out, 1 minus 1 0, then this cancel out, then we have 1 equals to b upon a, 1 equals to b upon a, or b equals to a. So we have both values, a and b. So here this turned out to this partial fractions, and we have the value of b or a here, okay. So then we write it, I am writing again, dx upon x plus a as it is equals to, and we put the values of a and b here, okay, and on integrating, okay, then we have a equals to 1, okay. So then integration 1 upon a dy plus integration b is b is a, so a upon 1 minus ay dy, okay. So on integrating this, log, this convert to log x plus a equals to, this is log y, or this plus, okay, this a is common, okay, and after that we just integration of this one is log 1 minus ay into this is into minus a, yeah, minus a, or plus log c, okay, and remove here, मैं इसे मिटा देता हूँ, and equals to log, okay, equals to log x plus a equals to this log y, and minus a square log 1 minus ay plus log c, okay. Then we have the property of log, and by the property of log we can easily have the answer log, okay, log y c upon, because when there is a addition between the log, then it convert to multiply, and where this is minus, then it goes to denominator, and this is a property that it goes to the power of this 1 minus ay. So 1 minus ay ki power a square, okay. So then after solving this, x plus a, this log cancel out, equals to yc upon 1 minus ay a square. This is the solution, okay. This is the solution of this differential equation. So it is a variable separation method, students, okay. Now we move to another method, which is very important method, and which method, because this variable separation is only works when we easily able to separate the variables. But the method which I am going to start is second method. It is a linear differential equation method. Linear differential equation. Okay, this method is easily and convenient, and we can apply this method to any question which is linear. Okay, what is the linear form? First of all, we start with the case. There is two cases. Case 1. What is the case 1? dy by dx plus py equals to q, where this p and q are the function of x. Okay, both are function of x or constant. So with this type of equation, we are just introducing if. When we solve this type of equation, we need if. And what is if? If is e raised to the power integration p dx. This is the if. And what is if? If is the integrating factor. Okay, and solution b. What is the solution of this equation? Is y into if is equals to integration q, this q, into if dx plus c. Okay, these are the two important factors to solve this type of differential equation. Okay, first we know the solution, how we get the solution, and second one is first one is the what is if? If is integration p dx. This is the case 1, students. Okay, and the case 2 is, I am writing as well here, case 2. Case 2 is the differential equation is that type: dx upon dy plus px equals to q. Here what change? Here y is dependent on x, but here x is dependent on y. And where we are using x, we replaces x by y and y by x. So why same here, integration if is, what is that if? Integration. Now this is p dy. Remember students, this thing is very important. If is integration p dy, and solution we have solution b. Here solution is x into if equals to integration q into if dy plus c. This is the solution when the equation is of this form. So we have two different forms. Now we start with the example. Okay, it is very easily understandable when I solve some one example here. Okay, just I take the example dy by dx plus y upon x log x plus equals to 2 upon x. This is the example, and this is a linear form. Okay, we can easily recognize it. How? Dy by dx plus py equals to q. So here p we have 1 upon x log x. Okay, and q is 2 upon x. Okay, here p and q are, we easily recognize them. Okay, so then first of all we start with the if. Okay, why? What is if? E की power integration p dx. Okay, so e की raised to the power dx upon x log x. Okay, and how we integrate it? Just simple, we put this log x as a t. Okay, we put this log x as a t. Okay, log x equals to t, then 1 upon x dx equals to dt. Okay, so then e की power integration, then this dx upon x convert to dt, and this log x convert to t. So 1 upon t is e की power log t, and as you know that this e and log are just cancel out each other, so this we only have t. And what is t? And t is log x. So students, we have if log x as if. Okay, so now we solve it. Okay, solution b. What is the solution of this equation? we have a solution is y into if equals to integration q into if dx plus c. Okay, so y into if what is log x, so y into log x equals to integration q we have 2 upon x into log x plus c. Here we need to integrate it, very simple, as log x we put a log x as t, so we have this 2 comes out. Okay, then here I just like I would like to do put what dx, so dx upon x dt, and this log x into t plus c. Okay, so y into log x is equals to 2 the integration of t is t square upon 2 plus c, this 2 cancel out, y into log x equals to, and what is t is log x. Okay, t is log x, so log x ka log x raised to the power 2 plus c. So here we have the solution of the differential equation which is representing this one. Okay, so student, this is the methods, this is the only 2 methods, and there are lots of other methods which is homogeneous form and exact differential equations, reducible to homogeneous, and which is also reducible to linear differential equation. There are lots of methods, but these 2 methods are easily understandable, that's why I use them. So thank you, students.